So we're going to start looking at functions by first looking at the sine function. So basically the function is going to relate the angle going around the circle to the sine value or the y coordinate. So we take a look at our circle here. This is going to be a unit circle. As we rotate around the circle, we're going to see what's going to happen to the sine value or the y position. So that's our relationship. As the angle x changes, how does the y position or the sine value change with it? And what kind of graph will it map out? So we want to look at the unit circle. Again, just defining the unit circle. The x coordinate is defined by the cosine value. The y coordinate is defined by the sine value. So what's going to happen as we rotate around the circle? So imagine starting at 0 and going through the first quadrant. What's happening? Well, the y value is increasing all the way up to 90 degrees. And this is what's happening on the graph. So as I move along the x-axis here, the angle is along the x-axis, so here's theta. The y-axis represents the sine value. And as we increase the angle, the sine value increases all the way to 90 degrees or pi over 2. So there it is. There's our pi over 2 up there. That's our quadrant 1. So we're just going to keep going here. So as we hit 90 degrees, what's happening as we move through quadrant 2? Well, if I look as I go through quadrant 2, the y value is decreasing all the way to 0 when I hit pi. And this is what's happening here. So I'm going to start at 90 degrees. As I go to the right, my y coordinate or my sine value decreases all the way to pi. Okay, and we hit 0 at pi. So that represents quadrant 2. So the green represents quadrant 2, the red represents quadrant 1. And as I go through quadrant 3, I'm going to do this quadrant 3 in blue, the y position as I keep going to the counterclockwise direction is going down, and it's not only going down, it's becoming more and more negative as I go from pi to 3 pi over 2. And so that's what's happening here. This y value or the sine value is getting smaller and smaller, more negative, all the way to 3 pi over 2. Okay, that's quadrant 3. And then lastly, I'm going to go through quadrant 4. What's happened to the sine value or the y position as I go through quadrant 4? It is increasing as I go counterclockwise here, all the way back to our starting position. Okay, all the way back to a 0 position, and we can then start again, which ends up giving us our next period, okay, or the next time around the circle. So there it is. So as I go around the circle, I can see how the y coordinate or the sine value is being mapped out by this function. And this curve is what we call a sinusoidal curve. Okay. So the key parts of this then again is if we look at the sine value, it increases till you hit pi over 2, okay, up there in red. And you can see that at pi over 2 we max out that y coordinate. It decreases to 0 and goes negative as we pass pi over 2, as we pass top pi. There it is, we hit 0 all the way down to negative 1. And from 3 pi over 2 to back to 0, the y value increases all the way back to 0, okay, when we hit 2 pi. And then because this is cyclical, that pattern will then repeat itself as we go through another period. So some of the key parts of the sine graph are going to be, what we're looking for is the period is going to be from 0 to 2 pi. Okay, each quadrant is divided up by 90 degrees or pi over 2. Some key parts are, well, we want it to be able to understand the transformations. We really want to have some key parts to keep track of. And the most obvious parts are going to be the 0, 0 coordinate, the starting point, our max point, which we get at 90 degrees or pi over 2, our 0 again at pi, our min point at 3 pi over 2, and back down to 0. So those are 5 key points that we're going to use. And we're going to start describing parts of this graph, give it some words. The height of this graph from the middle is something we're going to call the amplitude. and the amplitude is equal to 1. Okay, so the max the sine value can be is 1, and as we go down, the amplitude is still 1, but in the negative direction, we end up with a value of 2. So the amplitude is 1. I'm just going to list out some criteria, some things here. The amplitude is 1. The period is equal to 2 pi. Okay, so those are going to be some key aspects of this graph that we'll keep track of. Like I said, these coordinates I've given you, max, min, y-intercepts, and x-intercepts. These represent reference points that we want to make sure we keep track of. Okay, so maybe I'll just highlight that. And these are reference coordinates. Okay, so moving on, we can look at the cosine values. Okay, so what's happening with the cosine in the unit circle? The cosine again represents the x-coordinate. So what's happening as we go around the unit circle to the x-coordinate starting at 0? Okay, so I'm going to do quadrant 1 in red. I'm starting at 0 here. So we start with an x-coordinate of 1. So that is a position to the right 1. And what's happening as we go to 90 degrees? It's moving to 90 degrees. And the x-coordinate is decreasing from a positive 1 all the way back to the middle, or 0. That's quadrant 1. As we move through quadrant 2, the x-coordinate is further decreasing and becoming more negative all the way to the most negative, or the most left-hand position at pi. So the negative values get to a minimum of -1 at pi. So that's what's happening, being described here. As we keep on going, oops, I better show that on my function as well. So I started at 1, go all the way down to 0 at pi over 2. Quadrant 2 is going to be this section here, all the way to the most negative. We're going to have -1 at pi. The x position, as I move through quadrant 3, okay, our x position is becoming less negative all the way to 0. So 3 pi over 2 is going to be back to 0. That's 3 pi over 2. And then the final quadrant here, we're going to go from 3 pi over 2 back to 2 pi, and it's becoming more, the x position is becoming more and more positive as I move along the circle there, and so the positive x values show up on here. Okay, as I get more and more positive all the way to 2 pi, and the cosine value is back to 1. So there it is. That's how we're going to generate the cosine and sine graphs. Again, like with the sine graph, we want to have the period, the amplitude equals 1, the period, and maybe I'll start using the notation for period. We use the variable t. Big T represents period, so the period is 2 pi, and the amplitude shows up as the distance from the middle to the top or bottom. Okay, so there's my amplitude of 1. These coordinates represent my reference coordinates again. Okay, the top, middle, bottom, middle, top. So these are my reference coordinates. These are the ones we want to keep track of when we do any kind of transformation.